Hello friends, good afternoon to one and all. Good to see you again. Let me introduce myself. My name is P. Hemabindusvero. My mentor name is B. Ramesh Kumar. And I am from TTWREIS COE Girls from Vanaparthi. Today we are going to discuss an interesting topic from the branch of physics. So let us start through introduction. Nature is not a place to visit, it is a home. Nature will always be a part of our life. It is up to keep our environment clean and safe for our future generation. Imagine the world without nature, without trees, without clouds, without green grass, and without the beautiful flowers, and everything what nature have to be. What would be the meaning of life? Nature is very important for all of our humans. Medicines, food, water, and all these come under the nature. So, we can see the nature, enjoy the nature and feel the nature with the help of five senses. We humans are having five senses. Those are eyes, ears, nose, tongue and sense of touch. These are the five senses which humans are having. Among these, we can see the eyesight with the help of eyes. We can see the next slide that we perceive almost 80% of eyesight with the help of our eyes. Here eyes play a key role and vital role in our day-to-day life activities. So here I said about the nature and the five senses. I think you may not understand my topic. To understand my topic, you have to watch the video until the end. So here, to go through the introduction, let us continue with a small story. Once upon a time, a girl named Nazira. She is very fond of visiting new places. So, from her institution of Gurukulam, they gave a project to visit a new places like caves and domes. She is very fond of visiting new places. So, she went to the dome or cave which is far away of 150 kilometers from her house. Then, she went near to the door and she just knocked at the door. It's not opening because it is covered with a big rock. So here she used a force and she just opened the door and she slowly went inside. Then suddenly the door was closed. And this girl Nazira is very fear of darkness. Then she took the stick and lit the light. Yes guys, now we are going to discuss about the light. The presence of light only when she lit the light, she can see the objects around her which is present. So here I said about the nature. Nature we can see with the help of our eyes. Where we can see the objects? In the presence of light. So I said about the story of Nazira. So here we can take as an example of with the example of a story. She can see with her eyes. Now let us have a next slide. Here light is a form of energy. It enables us to see all the objects around us is known as light. Here in this light we are having luminous objects and non-luminous objects. We can see brief explanation about each in the next slide. First of all we can see what are luminous objects. Luminous objects are objects which exhibits light in their own. Example, torch is the luminous object. Bulb is the luminous object. And we can also see that candle is also a luminous object. These are the three types of objects and there are many objects which have taken only three. Let us see next slide. Non-luminous objects. Non-luminous objects are objects that reflect light from luminous bodies. Example are rivers, sun and moon. These are the examples of non-luminous objects. Next, we have a next slide please. Ray. A ray is a line with an endpoint that extends infinitely in one direction is known as ray. So, we can see the objects. When our eyesight goes through an object and the ray falls on our eye, then we can see the objects. So, let us see the image of the ray. In the first image, we can see the ray, only the ray. And second image we can see the beam of rays. So here you can see a ray is a line with an endpoint that extends infinitely in one direction is known as ray. let's have a study about the optics. Optics is the science of light. Here you can see the optics image in the slide, and here you can also see optical instruments. What are optical instruments? You may get doubt. That is, here optical instruments are classified into three types. Those are microscope, telescope and cameras. You can see in our day-to-day life activities that telescope we use to see the farer objects like stars, moon and asteroids. We help these things to see with the help of telescope. And we can use microscope to see the nearer objects. With the objects which cannot see, with the naked eyes, we use microscope to see the objects. Next, cameras. In these days, we can use cameras mostly because we are using to capture the images. So, I think you all understand that what we are going to discuss now. Yes, friends, now we are going to discuss about ray optics and optical instruments. This is the chapter of class 12 from the chapter 2. I said about the nature, eyes and senses of human bodies. Among that we perceive almost 80% of eyesight to interact with the world. In the presence of light, we can see the objects clearly. And here, with the help of rays, we can see the objects clearly. Now, we are going to study about the ray optics and optical instruments. Come on guys, now enter into the top chapter. Here, you can see in the slide the image of Ibn al-Haytham. He was called as the father of modern optics. He is an Arab mathematician, astronomer and physicist of the Islamic Golden Age. Ibn al-Haytham discovered the pinhole camera. He is known as the Arab mathematician and astronomer and physicist of the Islamic Golden Age. This is the introduction of Ibn al-Haytham. Next we see here about the mirrors. Basically mirrors are classified into two types. We all know that. In the previous class in the 10th we have studied about this briefly. So let us recall again here as mirrors are classified into two types. Those are spherical mirrors and plane mirrors. Again spherical mirrors are classified into two types. Those are concave mirror and convex mirror. Here, let us study in detail each term in the next slide. Here first, what is a mirror? You get that. Here you can see what is mirror. See here I have taken a mirror. This is the example of the mirror. We can use plane mirror in our day-to-day life activities to see our images. See I am seeing in my image. Oh, I am looking so pretty. The actions which are done by us, we can see with the help of a mirror. So, first we know what is the definition of mirror. A mirror is a glass which is polished or silvered in one side. You can see here, this is a mirror which is polished or silvered on one side. Here you can see the object which you can see like this. You can see your image like this. And it is polished or silvered one side. This is called as a mirror. If you get doubt, you can see the images are present in the slide also. Next slide, we go to the properties of mirror. Image formed by a plane mirror is always virtual and erect. If I see my object, if I am standing in front of the mirror, if I stand here, my right hand will be here. If you see in the mirror, your right hand will be the left hand of image. And the size of the object is equal to the size of the image. The third one is the image is laterally inverted. These are the three properties of mirror. Next slide moves to the types of mirrors. Just now I said what is mirror. Now we can see the types of mirrors. Spherical mirror and plane mirror. In the slide you can see the spherical mirrors and the plane mirror. Just now I showed the example also, and you can see a small boy looking into the mirror is an example also of plane mirror. Let us study each term detail in the next slide. Here you can see the spherical mirror. Spherical mirror is a mirror which is spherical in shape, is known as the spherical mirror. We can use spherical mirrors in our day-to-day life activities, and we are using two. Next one we are going to see about here you can see the types of spherical mirrors. An example in our day-to-day life activities we can take as cake also. For example, you can do as practical. You can see here, this is a spherical surface. This was cutted into the pieces. You can see, we can cut the cake also like this. If you take any part from these like this, here you can find the reflecting surface. Here you can see, I have taken from the surface of the circle, I have taken a part. Here you can see the reflecting surface. It is bending, it's not straight, it's bending. So the reflecting surface which is curved inward is known as the concave mirror, and the reflecting surface which is bulging, which is reflecting surface curved outwards, known as a convex mirror. Let us study this about detail. See now, let me study about the pole here. A pole is nothing but the center of the spherical surface of the mirror is called pole of the mirror. You can see this is a plain one. Here you can take this and can keep here. This is called as pole. The center of the spherical surface here the center of the spherical surface of the mirror is called the pole of the mirror. Principal axis. The horizontal line which is passing through the center of curvature is known as the principal axis. Next here you can see the image of the principal axis and focus. Focus is nothing but the converging of rays is known as a focus. Here you can see here, these are the pins which converge at a point here. With the experiment we can see this is a rubber foam. This is a rubber foam. Pin it to the foam. These pins we should be pinned to the foam, and if you compress this foam you can get the converging point. This point is known as the focus. Yes guys, now we are going to discuss about the focus with an experiment we have discussed. Now we are going to see about the center of curvature. Center of curvature is the center of the sphere of which the spherical mirror is a part, is known as the center of curvature. Radius of curvature, the distance between the pole and the center of curvature is known as the radius of curvature. Just now we said that about the definition of pole and center of curvature. So the distance between the pole and center of curvature is known as the radius of curvature. In the next slide we are going to see about the paraxial rays. Paraxial rays are nothing but the lines which are nearer to the principal axis. The lines which are nearer to the principal axis, these are known as the paraxial rays. And marginal rays are nothing but which are at the corners. In the image you can see the example also here, which is far to the principal axis, or we can say at the end of the concave or convex mirror we can see the marginal rays. Here image. We can see our image in a mirror. The general impression that a person, organization or product presents to the public is known as the image. Next definition shows us about the real image or virtual image. We are having two types of image. Those are real image and virtual image. Real image and virtual image. Here real image is nothing but real image are formed when the light rays are actually converge. Just now we saw about the rubber foam, the converge. Here also real images are formed when rays of light actually converge is known as a real image. Here you can see a small boy seeing his image with the help of the mirror. So he can find there the real image. Virtual image is nothing but virtual image is an image formed when the outgoing rays form a point on an object always diverge. Here in the slide you can see the image which is the object is very large, and after the virtual image is looking so small. So this is called as a virtual image. Virtual image is an image formed when the outgoing rays form a point on an object always diverge. Next you can see about here the object distance and the image distance. The distance between the object and the mirror is known as the object distance, and the distance between the image and the mirror is known as the image distance. These are the two distances in which we are going to study about the mirrors. Just now we said in the front, we are going to discuss about that later. But now we are going to see about the myopia. Nowadays childhood children are not only children but all the people are facing problems that the defect of eye lens. They couldn't see some people couldn't see the far objects, they can see the near objects, and some people cannot see the far objects, can see the near objects. Like this they are facing somewhat of the problems, right? So now we are going to study about the myopia and hypermetropia. The defect of eye lens to form an image in front of retina is known as myopia. I would like to repeat again. The defect of eye lens to form an image in front of retina is known as a myopia. This is an image of the myopia. Now we are going to study about the hypermetropia. The defect of eye lens to form an image behind the retina is known as a hypermetropia. Here in the previous slide you can see myopia. This myopia can be corrected by the concave lens, and hypermetropia is corrected by the convex lens. This is all about the terms of the mirrors and lenses of myopia and hypermetropia. Now we are going to have the types of mirrors and what are they. They are classified into two types. They are concave mirror and convex mirror. Let us study this in detail about in the next slide. Here you can see the slide concave mirror and convex mirror. Concave mirror. Here we can see the reflecting surface. This is the reflecting surface which is curved inward is known as the concave mirror. Here you can see the reflecting surface which is curved inward is known as the concave mirror. And these concave mirror, the uses of the concave mirrors are used in shavings, makeup mirrors, dental mirrors and car headlight mirrors. These concave mirrors are which is reflecting surface, or it is also called as the converging points. The converging of rays is known as also as concave mirror. Next we are going to study up the convex mirror. Here the reflecting surface which is curved outward. Just now we see that the reflecting surface which is curved inward is known as a concave mirror. Now we are going to see about the reflecting surface which is curved outward is known as the convex mirror. The reflecting surface which is curved outward is known as the convex mirror, or it is also known as the diverging mirror. The uses of these concave and convex mirror we have seen. I didn't say about the convex mirror uses, right? Let us have now. Uses of convex mirror are because convex mirrors produce small, virtual, upright images. They are well suited for security mirrors, real view mirrors. Let us see in the next slide about the properties of light. Here we have studied about this all. Now we are going to study about the properties of light. Here those are classified into 8 types, and they are effects of materials on light, reflection, refraction, dispersion, total internal reflection, interference, diffraction, scattering of light and polarization. These are the properties of light. Now we are going to discuss each term in clear and detail. Reflection of light. The phenomenon of light rays coming back after hitting a plain smooth surface is known as reflection. We all know about this, all studied in the class 10th. So now again in the class 12 in the chapter 2 we are going to study in detail. I said previous, right? So now we are going to see here the phenomenon of light rays coming back after hitting a plain smooth surface is known as the reflection of light. Here you can see the image of the reflection of light. Next we are going to study about the laws of reflection. Here in this reflection we are having 3 laws. They are first law, second law and third law. First law explains us about the first law of reflection says that angle of incident is equal to angle of reflection. See, in the first law we can see I is equal to R. Incident ray is equal to reflected ray. In the second law of reflection we can see it states that the incident ray, the reflected ray and the normal to the surface of the mirror all lie in the same plane. What they are lying? The incident ray, reflected ray and the plane normal lying in the same plane is known as the second law of reflection. Third law of reflection is nothing but the reflected and the incident ray are on the opposite side of the normal. We can also say in the slide, and I am going to say about now, from the P, the incident ray is falling on the Q to the normal, and it is striking again to the R as a reflected ray. This is known as the third law of reflection. These three laws can be derived from the Fresnel equation. The Fresnel equation describes the reflection and transmission of light when incident and interferes between different optical media. These three laws were derived from the Fresnel equation. Now we are going to see about the refraction of light. Refraction. Before I am going to say about this, let us do the small experiment. Take a beaker and add some water in the beaker, and then take any object, like I have taken pen. You keep here pen in the beaker. You can see here enlarged. You can see differences here and there under the water also. So what is this called as? Can you all? No, just I want to say about this. Listen properly. I have put pen inside. If I remove this pen, you can see this. It is in the normal. If I dip in the water, you can see here the differences above the water and below the water. So this is known as a reflection. It is nothing but refraction. Yes, refraction is the bending of light as it passes from one place to another. And the image of this refraction of light is, these are the examples. Not only with the help of pen, we can use anything, straws, pens, sticks, and everything under the water. It looks as enlarged. This is all about the refraction. In the next slide, we can say dispersion. Splitting of white light into 7 different colors is known as dispersion. Those 7 colors we can say as VIBGYOR. It is also in the form of rainbow also. Red, orange, yellow, green, blue, indigo, and violet. We can see dispersion in our day-to-day life activities examples as bubbles, and this CDs you can see here indigo color, rainbow color formed here. And next we are going to see about, through prism also we can see total internal reflection. When a light ray enters from a denser medium to rarer medium, the angle of reflection is greater than the angle of incidence, is known as the total internal reflection. Here are the examples of the total internal reflection: mirages and the turtle under the water. Interference is a phenomenon inside which two waves superpose to form a resultant wave of greater, lower, or the same amplitude, is known as the interference. These are the two types: constructive interference and destructive interference. Diffraction of light is nothing but, diffraction is a slight bending of light as it passes around the edge of an object, is known as diffraction. Scattering of light. The scattering of light is a deviation of light rays from its straight path, is known as the scattering of light. Polarization is nothing but the phenomenon of the restriction of the vibration to a particular direction is called as polarization. So at last I would like to conclude that this is all about the ray optics and optical instruments which we have studied or discussed now. So I would like to thank for the TSAT group and to our mentor sir. Especially I would like to give a thanks to our beloved secretary sir.